In this presentation on Kamiak Butte, I will be covering the geologic foundations, climate of Kamiak Butte, as well as a field report of the site and specific species found on the butte. Kamiak Butte was formed due to flood basalts, or magma flows from hotspots of viscous basalt that erupted from the ground starting about 17 to 14 million years ago, with less extensive eruptions lasting till about 6 million years ago. These basalt floods engulfed much of Washington, Oregon, and Idaho, and can be seen in an image on this slide. These basalt floods were very extensive and covered up a lot of the ground around. During the most recent ice age that occurred about 2.56 million years ago, an ice cap covered North America through an estimated 11,700 years ago. During this time, glaciers descended from the north and engulfed the Pacific Northwest, carving out channels, valleys, where gravity took the giant glaciers. An image of this can be seen on the right-hand side, where the ice sheet descends from the north down through the south. Following the Ice Age, there were glacial floods. As the last Ice Age came to an end, about 11,500 years ago, glaciers began to melt and form Glacial Lake Missoula, which buoyed up a glacier and allowed a massive amount of water to gush out in a flood so powerful that it was responsible to carve out the scablands that we see today. These rushing water, collected a tremendous amount of debris from washing over the lands when it hit a choke point called the Wallula Gap. Debris piled up at the Wallula Gap, forming a sort of dam of dirt, logs, and other materials as the water sat and passed through holes below. In the finishing touches of Kamiak Butte, there was a deposit of the loess soils. After massive floods that unleashed tons of water through the Pacific Northwest, the debris that obstructed the Wallula Gap had begun to decompose and turn to soil and silt. This was called the loess soils. These soils very fertile and began to pile up in what is now Lake Lewis and sit there. At this time, climatic winds began to pass through the Palouse. Once the loess soils were deposited, major winds came up through the Pacific Ocean and up through now the Columbia River, where it blew back all of the soils across the Palouse. These extremely fertile soils now covered the rolling hills of the Palouse and much of Kamiak Butte. These soils have helped the agriculture industry in eastern Washington to become one of the most efficient wheat industries in the world. This is due not only to the soils that were blown in from the Wallula Gap, but also because the flood basalts that scoured the lands. These basalts are thick and do not allow rainfall to pass through the rock very fast, whereas the quartzite on the actual buttes itself allows for the water to flow very quickly. This is why the farmlands surrounding the butte are so fertile. Air masses at Kamiak Butte are an important factor in its climate. Atmospheric pressure helps to create winds in a convection-like pattern where warm air rises and cold air sinks. This convection helps to transfer warm air from the equator to the poles and cold air from the poles to the equator. These differences in atmospheric pressure create the winds that we see at Kamiak Butte, and boy, there's a lot of wind there. It's mostly marine polar winds that come down from Alaska across the Olympic and Cascade mountain ranges. These winds are usually cold and named the westerlies. Clouds are also a key component to warming and cooling the planet. Clouds act as a barrier between the sun's solar radiation and the surface of the Earth. They reflect that violent radiation back out into the atmosphere. Clouds also bring water, which is essential for the growth of plants. Although it may not seem like it, but topography can impact the climate of an area. The aspect and slope inclinations affect how much sunlight, or direct sunlight that is, that an area can get. The more the sunlight, the harsher the conditions are. The aspects of Kamiak Butte are vastly different due to these conditions. Where there is less direct sunlight, there is a lush forest on that aspect. Where there is a lot of direct sunlight, there is not many plants growing on that aspect. The rain shadow effect creates a drier climate on Kamiak Butte through this separation. The marine climate has a lot of moisture for being close to the ocean. When those air masses are pushed east by the winds, it brings all the moisture with it. When the air mass reaches the Cascade Mountains, the clouds dump all that precipitation so they can get over the mountains. Smaller clouds continue the journey eastward with much less moisture in the air, and that is why the eastern Washington, and more specifically Kamiak Butte, is a drier climate. Climate is how the weather of a certain area is over time. It is what you can expect in a certain area as far as temperature, humidity, rainfall, wind, and other conditions. Solar energy that is modified by topography, soil, and vegetation determines the temperature, which influences said factors, including wind, moisture, to ultimately determine the microclimate of Kamiak Butte. In the table below, the data taken from PRISM datasite, I compiled the average temperatures and average precipitation per month. It is shown that Kamiak Butte has a relatively low inches of rainfall with low temperatures in the winter and moderate high temperatures in the summer. In the second table below, it is shown that the climate of Kamiak Butte, the image shows is what is expected in terms of weather through the years of data collection. This figure also shows the drought of the Palouse in 2021. In this year there were low levels of precipitation as well as very high temperatures. This next section is the field report of Kamiak Butte. From a geological background of floods, glaciation, loess soils, and a climate that influences the terrain, Kamiak Butte is a spectacle of ecology. These factors have created the butte, what is known as home to a variety of species across the landscape. When the natural structure was seen two seemingly opposite sides, a north and south face, that differ from each other drastically due to the climatic conditions such as sunlight exposure. These two aspects may be part of one landmark, but the microsites are home to two different variety of organisms that call it home. The topography of Kamiak Butte is an essential function of how vegetation grows at the site, as well as biotic and abiotic factors from around the butte. The north-facing aspect at Kamiak Butte is much more lush. The abiotic conditions that help shape the north aspect of Kamiak Butte are plentiful. An abiotic condition is the process of a thing in the microscope that is not alive. There are some shared abiotic influences between the two aspects that play in part of the makeup of the mesoclimate. The geologic foundation of the butte is quartzite rock. The rock type makes water flow faster away down to the flood basalts below. This plays a vital role in shaping the north aspect, with calm winds on the north aspect. Vegetation is more easily able to stay rooted in the ground, and soils stay put. With all major influences of this aspect is the lack of photosynthetically active radiation. The shaded area allows for a more diverse population of vegetation to grow. The tree species present on the north aspect are Douglas fir, western larch, and ponderosa pine. There are a total of 130 trees per acre that were divided up amongst these tree species. The most common of these tree species is the Douglas fir, which makes up 71% of the trees in the area. Douglas fir trees can be in the shade where there is not a lot of solar radiation, so in this environment where there is not an abundance of light, this species thrives. The DBH, or trunk size, of these Douglas fir trees was larger on average than the rest of the species, with an average diameter of 20.68. Tied for second most trees in the area were the ponderosa pines, that made up 14% of the trees in the area. Ponderosa pines like to be in the sunlight much more than in the shade, so they go taller in heights in this environment than the rest of the trees to compete vigorously for the radiation. The ponderosa pine trees on the north aspect had a DBH of 15.6. The tree is not very wide, but was the tallest of the group at 112 feet. Lastly, the western larch also makes up 14% of the tree canopy on the northern aspect. This tree is also able to withstand lower amounts of sunlight, so it does not grow to be enormous, with one sample collecting at 80 feet tall and had the smallest dBH at 14.6. There was also an important statistic of the QMD, a quadratic mean diameter, of 19.5279, which is the quadratic mean diameter of the northern aspect trees. The southern aspect is much different than the northern. The figure shows the vast differences between these two sites. This is because of the temperature and sunlight difference that the aspect does receive. The main abiotic influence on this site is the amount of sun that it does get. The great amount of solar radiation makes it so plants are not able to grow as good. There are also much higher winds on this site than the other one. This causes for plants to not able to be taken root as easily. Tree species variation in the south aspect of Kamiak Butte is non-existent. In Table 2, it is shown that the only tree species present can grow in these conditions is the ponderosa pine. The ponderosa pine trees love to be in the sunlight and can tolerate the excessive heat that goes hand in hand with that light. With no other trees present and conditions as they are, there are only 35 trees per acre in this location. The average tree height is also much shorter, with an average of 34 feet, since there are not a lot of surrounding trees to compete for that solar radiation. This brings the trunk size of the trees to an average of 17.04. The south aspect had a QMD of 18.15071. The ponderosa pine is also a unique way of dealing with competition of having a chemical released in the pines that prevent other trees from growing around them. Finally, I get to talk about my favorite part of this presentation, the specific species at Kamiak Butte, the Rocky Mountain elk. The predators for elk at Kamiak Butte are numbered to very few. With the elimination of wolves, very few wolf populations exist in the area. This leaves the predators at Kamiak Butte to be mostly coyotes and cougars. Both of these animals will kill an elk. However, the coyote is just limited to killing calves. Cougars, on the other hand, can kill even the biggest of animals. They are not great in numbers, so the populations are hardly impacted. In this picture, it is seen that a cougar is stalking 2 bull elk. The overall niche of the elk is very important. Elk fill an important role at Kamiak Butte by determining the plant growth by both fertilizing and eating the same plants that they eat. Elk at Kamiak Butte are also an important food source for other animals nearby. This niche is specific and fills an important role in the overall environment at Kamiak Butte. The niche of an elk is explained by Peyton Detremere as the niche of an elk is a roaming herbivore. They eat the vegetation from under the ground to the lower branches of trees. The major competitors that the elk have are moose and deer. As a roaming herbivore, it does not stay in Kamiak Butte, but it does make the butte what it is today. Thank you.